So I'm Marieke Gaudet-Kirkman. I'm the VP of Business Development located in San Diego, California. And I'm here with Chris White and James Graves to talk about all things GMP. Chris, can you introduce yourself?
Absolutely. Hi, my name's Chris White. I'm the head of GMP at ADAMAS Consulting. I've been in the pharmaceutical manufacturing industry going on 17 years now, mostly in aseptic processing in different capacities within the QC laboratory, production management, and quality management. So nice to meet everybody.
And James, go ahead.
Hey, I'm James Graves. I am a GMP consultant / auditor at ADAMAS, and I've been in the industry for about 16 years in primarily validation and quality roles. I started out in working at Quintiles, and I worked at other places like Teva and Bayer and several other smaller firms as well.
Well, we're all honored to have you guys on board. It's a true honor in speaking to you today. And so here we go. Let's talk about aseptic processing. So what is aseptic processing?
Yeah, so I can speak to that. Aseptic processing is a manufacturing process for products intended to be sterile. And there are, aseptic means without contamination, right? So we're making a sterile product in a way that prevents contamination, right? And if you can do that successfully, then you have a sterile product and you ensure product quality and patient safety. And typically, your sterile products are injected. So as opposed to, orally administered products or, topically administered or routes of administration that have natural, defense mechanisms versus against contamination. Sterile products, when they're injected, directly into your, intramuscular or intravenously, bypass those natural defense mechanisms. So there's a heightened level of risk with sterile products that you have. And so I guess overall, a good aseptic manufacturing process, provides, a high degree of assurance that your processes are in place to meet your end result in obtaining a sterile product so that the patients that take that product are safe. So that's kind of a long roundabout way to describe it. Did I miss anything, James?
Well, I throw in that, the aseptic part of the process is specifically talking about excluding microcontamination, so microbial contamination. With a lot of the procedures and controls that we use for excluding that microbiological contamination, it also helps with other cross-contamination to really help a facility or process think about what are the inputs versus what are the outputs, because the output is you want something that is safe to inject into a person to bypass all their defenses, like Chris was saying. So you have to be very careful on what goes into it. And that kind of focus also helps with chemical cross-contamination as well. So
awesome. And so what are some of the risk points that you might see in the process of manufacturing an injectable, for example?
Yeah. Go ahead, James. I'll let you go first on this one.
Well, I think when you start with manufacturing any product, the raw materials are pretty important. The grade at which you purchase and the source that they're purchased from are pretty important. So having a robust external audit team to look at material providers is pretty important. You don't want to purchase a lot of, let's say, vitamin E from a particularly dirty facility that no one's ever seen. And how would you know if it's dirty if no one's seen it? So certificates of compliance, trying to find other ways of leveraging assurances that the facility that materials are coming from are clean and that the grade of the material is what it should be as well. So I'd say that's where everything starts.
Yeah, and I agree with that. So you have materials, and I think also when you're talking about aseptic processing, the people involved in the aseptic manufacturing process are typically, represent the biggest risk to contamination because, depending on the process, you have, facility controls, which provide sterile HEPA filtered air. You have rooms held under positive pressure, to, push the air out and keep airborne contaminants out of the room. But then you have people that are, inherent to the process, and they wear sterile gowns, hood to toe, where they don't have any, exposed skin. But still, even inside of a clean room with a person that's sterile gowned, that person still represents the biggest risk to the potential for contaminating a product during the manufacturing process, whether that be during formulation or whether that be during the actual filling process. And during the filling process is really, can be high risk because the product is temporarily exposed to the environment, right? And so you have, during the manufacturing process, if when during that critical step, you have facility controls in place, you have your equipment operating. If your equipment malfunctions in any way and people have to get involved, then there's what's referred to as interventions during the aseptic process, and where people have to, perform more invasive interventions, and that always provides an inherent risk to the process and contamination. So you have to have mitigation steps. You have cleaning and disinfection. You have environmental monitoring. They monitor surfaces, they monitor airborne particulates, all as a way to detect different types of contamination, primarily attributed to the presence of personnel. And the presence of personnel inside of a clean room significantly drives up the risk of introducing particulate and microbial contamination to the environment. So I think James hit it spot on. And then, with material, you have materials, and then you have people that represent the two, probably some of the two biggest risks, maybe. To build on that, on the material side of it, you want to check your materials upon receipt, and, you can test them for bioburden to see what their bioburden levels are before they're used. You can also test bioburden of the formulation in process before it's, rendered sterile through filtration, to see, as a means to detect what the levels of bioburden are before you use the materials. And then, the other piece I think is important with materials is the transfer of materials into your clean room. So a lot of the equipment and materials that you use inside of a clean room are typically sterilized, by either through deparogenation oven or by autoclaving, using moist steam to sterilize the equipment. But some equipment you have to transfer into the clean room, or materials that cannot be sterilized. And so you have to manually disinfect those materials. And I think that represents a common risk, not necessarily a high risk. In some case, it depends on the process, but I think transferring materials into your clean room is an important step that represents definitely a risk that's common to a lot of manufacturing processes.
I think one of the kind of counterintuitive things about aseptic manufacturing is, I think, kind of summed up in a portion of the USP, I believe it's chapter 70 for sterility testing. While the test is labeled sterility test, and people producing aseptic products, sterile products, need to perform a sterility test for release, the chapter itself says that a sterility test does not guarantee sterility. It is a sampling exercise. The only way that you can actually guarantee that a product is sterile is to filter and test literally every milliliter that you're producing, which is just not possible. So there's a huge burden that is put on a facility to look at all the processes, all the inputs, materials, personnel, equipment, flows, disinfection, all of the inputs for producing an aseptic product need to be monitored and demonstrated that you've got everything under control. And that is done through a micro lab, microbiology laboratory. And they're really important for being able to go out and sample and validate, perform studies, and trend data to demonstrate that a facility is managing to keep their processes under control, because they can't do 100% sterility testing. It's always going to be looking at what are the chances, and those chances are summed up in sterility assurance levels, which can potentially be calculated through all the different controls that you're doing on a system. The kind of one of the most guaranteed ways of coming out with a sterile product at the end of your process is terminal sterilization. But not every product has a way to be terminally sterilized. There are things that cannot be, for instance, heated for too long or treated with radiation, irradiation. So a lot of it is on the front end and on the process itself for producing products. And the micro lab really is important there in the quality of data and how they go about demonstrating the facility and processes are under control.
That's a really interesting point that you made about sterility testing, because a lot of, not a lot, but I mean, I think I've heard the misconception before anyways, that, well, we've never had a sterility failure during final product testing. That's great when a site is making, I don't know, say 20, 30,000 units in a batch, right? The number of units that actually get tested for sterility is typically 20 out of 20,000, 20 to 30,000. So you have assurance, 100% assurance that 20 of those vials out of 20,000 are in fact sterile. The other 19,980 vials, you have a high degree of assurance based on the other process controls, your cleaning and disinfection, your environmental monitoring showing that the environment was in a state of control during your batch, personnel, aseptic techniques employed. All that other assurance is provided through risk-based processing and having adequate process controls and the ability to monitor and detect shifts in the level of control of your process. So good point there, Jim.
And because those sample sizes are so small, if you do end up detecting contamination and it's valid contamination, what you've most likely detected is gross contamination across the batch.
So those 20 vials that end up being sampled, do those end up going down the chain and like delivered to actual patients, or are those destroyed?
Nope. Those samples, so what that sterility test involves is actually taking the contents of that vial and adding, and there's several different ways to do it, but basically you're adding that product to growth media. So once you've done that, you've opened the vial, right? In a controlled environment, so you don't contaminate it during the test, but you've opened the vial, you've then added the product to growth media to detect microbial contamination.
Gotcha.
And so it's a destructive test. It's what is called a destructive test.
Right. So then essentially there's never a test actually directly done on anything that's delivered to a patient, correct?
That's correct. That's
wow.
correct.
Wow.
Yeah.
So it seems like there would be always some nominal risk in that case.
Yes, and that is the statistical approach for verifying that a product has been made aseptically.
Hmm.
It's always going to be a numbers game.
Right. Okay, and then there's always just steps that are taken to ensure that, you know, those vials that are actually delivered to patient, because patient safety is essentially why we all do what we do. The steps are taken such that, you know, the ultimate drug that's delivered is safe.
Yeah.
Exactly. So it's a combination of a lot of different controls. Like James was talking about earlier, you have materials. Those materials are tested by QC, you know, before they're released to be used for production, to make sure that they have the identity, strength, that they're pure, and they're not grossly contaminated. You have, you know, people that are involved in aseptic processing are subject to rigorous training in general microbiology, clean room behaviors, aseptic gowning, and it's a really difficult job. It's hard work, but it's working inside of a clean room where you have to have a high level of awareness to everything that you do, because the primary basis for, you know, for facility controls is airflow, and the ability to work without disrupting that airflow, because that airflow pushes everything, the airflow pushes everything down. So if there's contamination in the air, it's being pushed down and then swept away through the air returns that are low to the ground. So if you disrupt that airflow and create eddies in the air, that can swoop down and pick up contamination and bring it to working level.
And that's the dream.
Yeah.
That airflow that you were talking about, and that is not the case in all facilities. You know, ideally you have supply up high and you've got returns down low. I think we've all seen facilities where there maybe aren't a lot of returns on the ground, and maybe there might be some up high. So you don't know what is going on with the airflow.
So, yep. And so you have, you know, you test the raw materials, you train the personnel, you have facility controls that are engineering controls. Like I was saying, the airflow, you have robust air change rates to make sure the air is constantly being refreshed and replaced with clean, fresh air, HEPA filtered air. And then you have product testing. So a sample size of your overall batch is tested for sterility. It's also tested for different product characteristics, strength, identity, purity, sterility. And so all those things combined, you know, testing of materials, facility controls, training personnel, all of that has to be, you know, goes into consideration when you release a batch for the market, so that patients can, you know, so that the drug can be administered to patients. And so QA in the United States, QA is responsible for releasing those batches. And so they have to look at that during batch release. They have to look at the environmental monitoring. They have to look at the facility controls, the personnel interventions that were documented, and make sure there's a high degree of assurance before that batch is released. It's a very big responsibility. And in the European markets, they have what is called the qualified person. And where in US, the responsibility lies with the quality assurance unit. In Europe, that responsibility lies with the qualified person. And so the difference being all the responsibility lies with one person in Europe, whereas the responsibility is shared by the, you know, quality assurance unit and, you know, the person that is the head of the site that releases the batches, you know.
Well, that's a really important, like, sort of regional difference that you've highlighted. So what do you think is probably the most, I mean, I guess there's probably positives and negatives to either approach. So what are some of the downsides of having a team-based responsibility rather than a single qualified person?
That's a good question. You know, I think it comes down to accountability. You know, in the EU, the qualified person, you know, the accountability goes all the accountability goes to the qualified person, right? And so that mitigates risk, I think, in some way, because the qualified person then has to make sure that the that the source of the materials, like James was talking about, source of materials is qualified, that sites have adequate training, adequate facility design, adequate facility controls in place. And so they have to audit, you know, and, you know, and do those checks before they release a batch. Whereas, you know, in the United States, a lot of responsibility lies with the quality director. They're typically the ones that are, you know, releasing batches or responsible for the quality unit, which releases the batches. And so the accountability lies with, you know, the site head, the quality director, but it's also pushed down to the rest of the quality unit to ensure that there's a thorough review of all the batches. And the QP also relies somewhat on the quality unit as well. But the responsibility ultimately lies with the QP if something goes wrong with that batch. Whereas, yeah, it's more of a site responsibility or a site function in the United States.
And so the QP or the not QP kind of discussion is, you know, visually, you know, I'm kind of perceiving that as like what are your responsibility eggs? Like, are they all in one basket where there's one person responsible? And hopefully that basket is well organized and they know where all the responsibility that they have to hold, you know, percolates up through the organization. But not having necessarily a basket where your site head has all the eggs laid out. They have a whole lot of, and they may not be, you know, necessarily from a quality background, your site heads. So, so they would have to depend on an assortment of, you know, directors, supervisors, where that quality responsibility is distributed. I mean, there can be positives and negatives for either of those situations. Because what if you lose your QP? What if the one person that, you know, has it all, has a whole, you know, world, quality world for a system in their head? What if they move on?
You have to find another QP.
Yeah.
You got to think about succession planning as well.
Yeah. Okay. Interesting. So let's go back to aseptic processing for a moment. So what are some of the, I guess, current challenges that are presented by you know, the current status of aseptic processing?
You know, go ahead, James. Yep, go ahead.
One thing that I think some people in aseptic processing might be a little frustrated with is how the EU GMP Annex 1 is still not revised. It has been in revision for years. It's gone through maybe 2 different revisions for public comment, and there's been some good improvements in the draft, but there's just been so much talk and not a lot of action in getting that annex out there. Because there's things like explaining the purpose of disinfectant rotation that is not really in the current Annex 1 for facilities to follow. So that would be nice to see because it's got clear instructions for sites.
Well, I mean, there's not much that has been updated since 2004, really, in the United States, though, either, you know, James. Not just the EU annex, you know?
Right. And, you know, unless you're getting into the USP, where even the USP has a bit of vagueness around some of their aseptic suggestions, there could really be better explanations of the contamination control strategy of a site, you know, including how and why they go about media fills, aseptic processing simulations, and, you know, material flow, disinfection, efficacy, those sorts of things. There's just, I think that there is a need for more direct, clearer regulatory suggestions.
Yeah. I think also one of the biggest challenges in aseptic processing is in industry is the ability of sites to evolve, especially over the past 10 to 20 years where there's been this technology boom, right? and all this new technology, this new capability is coming out so rapidly, right? And sites that have been around for 30 years or so, 20, 30 years, they have an aging facility, right? And that aging facility is prone to, contamination risks, right? You have to really do a good job of maintaining those facilities and sanitizing those facilities.
What are some of the risk points in the older facilities?
Well, with the older facilities, you have, over time, disinfectants and sporecidal agents. They're hard on your surfaces, and they can corrode surfaces. And you can have degradation of materials of construction over time. If your clean rooms, if there's any cracks that occur, or there's drywall exposed underneath the paint, that can easily, if any drywall gets wet, that can very easily cause mold buildup, right? If there's any moisture, and that can, the mold, it proliferates in a spore forming mechanisms, and those spores remain dormant until conditions present themselves, i.e. moisture is exposed to, or drywall is exposed to moisture, and then that mold proliferates, and you don't even know it's occurring until you detect it in your environmental monitoring. And at that point, you don't know how long it's been around, and it's very difficult to get rid of, right? And so, there's that type of thing for aging facilities. There's also, facilities, some of the new technology, like implementing the use of isolator technology, right? That can have a significant impact on the footprint of the facility. And so it's very expensive, and it's it takes a large investment, monetary investment in your site. And so I think industry is slowly evolving, and sites are slowly starting to, it is not a quick transition at all. And so those older processes, aging facilities, they have more manual processes. There's more risk in those processes. The facility design maybe in some cases is outdated and doesn't have segregated flows for clean and dirty material, or doesn't have segregated flows for personnel into and out of the critical areas. So I think it's both aging facility, degradation of materials, facility design, and footprint are things that come to mind when you ask about what are some challenges in aseptic processing, right?
Yeah, and the guidance doesn't necessarily move at a breakneck pace, but it does keep moving over time. White papers come out, regulatory agencies, they put out guidances or additional suggestions on how to do things. And if you're in a facility that's 40, 50 years old, there's only so much you can do. Hopefully you're keeping up with what is recommended, what the guidances are about how to go about, processing things aseptically. But if you've got a really old facility, you've also got to think about, well, how do you stay in production while integrating new ways of controlling your environment. If you need new air handlers, then that's going to be a big ask. You might have to shut down production for a while, or install new walls. It's a bit like, I know we talked about this before, but about redesigning and rebuilding an airplane while it's in flight. How are you going to go from a biplane to a fighter jet? It is not going to be an easy process, and it's going to have some risk in it.
Definitely.
Awesome analog. I love that. Okay, so what are some of the times you've seen in the field where you just want to say you're doing it wrong?
Yeah, I think what comes to mind for me, is just times when I've seen examples, either, I don't know, online or, in person, just out auditing. And things like, when you're, doing a facility tour and you're observing a clean room area, right? and you can see, people in clean room gowns, inside the clean room. You can't hear what they're saying, but obviously the way they're using their hands and doing this and blah, 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 and all these crazy movements. And they're just, talking about what they did this weekend while they're involved in making a batch of sterile product, right? All things that are you're not supposed to do inside of a clean room, and so I think that comes to mind. I think operator awareness and training will always be a challenge, because some of the operators inside clean rooms are degreed, chemists, microbiologists, scientists. Some of them in more commercial manufacturing environments are high school education level, more blue collar type workers that need that supplemental training in order to have the awareness that's needed while they're doing while they're working inside of a clean room, right? And so a lot of sites, well, maybe not a lot, but some sites struggle with that, because it's not it's not rocket science, but sometimes it's not an easy topic to learn or to teach or to train on. And so I think that's a big, that's a challenge, is personnel, because we go back to personnel being the highest risk inside of a clean room as far as microbial contamination. Well, to mitigate that risk, you need to have a robust training program for those people. And so I think clean room behavior is a big one, and I think clean room behavior also, if you look at the FDA website and you look at the different types of 483s, it's all over the place. It's all over the FDA websites as far as findings, 483 reports for lack of aseptic technique and poor clean room behavior. And so what do they do when they see that? Then they go to your training program and they get their shovel and they start digging. Right.
And oftentimes, operators that are brought into a company, it might be their first time that they've ever even heard the words aseptic processing, even if they've had a college education. That's just not something that is taught in colleges, as far as I can tell, because why would it? Why would they?
No.
So people are really dependent on the facilities that they are getting their training from to know what they're doing, because we would hope that there's good science behind every decision on how they go about, like Chris was saying, movement or talking or what they do with their hands. But these people, this might be where they learned aseptic processing, is in that processing suite from those trainers. And they might have asked questions in the past, and they might have been given reasons for why things are done in certain ways, and those reasons may not be scientifically justified. Having a different perspective from somebody who's seen a number of different ways to achieve an aseptic process is pretty helpful. Having that outside view, because otherwise, you've basically locked yourself in a room and locked all the doors, closed all the windows. You need to have that outside input from industry, whether that's going to trainings or having someone else come in.
Mm-hmm. Great. And then how about some, flipping the coin around, some really stellar examples of just handling something perfectly?
James, I'll let you go first.
Handling something perfectly. There's been a number of facilities that have really good aseptic processing suites. That's oftentimes where people put a lot of their money for building a facility, especially if it's new or if they are, remodeling. That's where most of the product contact equipment, some of the most critical product contact equipment, is in the facility. So you want to make sure that is really nice and visible. And I think it's that visibility that I like to see. If there is an aseptic suite that is hidden behind several walls and corridors, that's one thing. That's okay. That's going to get looked at every once in a while. But if it's really convenient to have it close enough to a corridor where there is the potential for visibility, high visibility of a aseptic processing suite, it's just like I've heard when people talk about how good is your kitchen in a restaurant. If it's behind a bunch of doors and nobody can see it, well, then what's the oversight? But if behind the counter there is a glass wall and you can see what everybody's doing, what everybody's touching, how everybody goes about what they do, then it's going to be cleaner, it's going to work better, it's going to be a better process. That sort of visibility is what I like to see in a facility, and I've seen that a number of places. So,
and
so
I think
sounds like in some of those places that maybe you've seen a few times, or you get such a bird's eye view of a lot of different facilities. It sounds like you might have some recommendations on, hey, you might want to go with this one. No?
Yeah.
Am I wrong here?
No. I think no, you're spot on. I think what does good look like? You have adequate space in your design. You have minimal people, the minimum number of people needed to perform the process. You have good aseptic behavior. And that's very easy to tell. I mean, when you're looking inside of a clean room, does the person understand aseptic behavior or not? You can tell that within 30 seconds to a minute of watching a process, right? It's very, very easy. And so, yeah, it's, are things organized? A lot of sites, start to implement, 5S, so that the area looks organized. It's not cluttered. There's not a bunch of clutter lying around and things like that. All right. So that's what good looks like. I think too, also, when you ask what does good look like, I think a sound, so how do you qualify an aseptic process? You do that through what's called media fill. So basically you simulate your actual process. Basically what you do is you replace you fill the growth media instead of the product, right? And by filling growth media, if at any point, if that growth media gets contaminated, it's going to grow big globs and slime of, slimy bacteria. It's going to grow inside of your vial, and it's very easy to see, right? And I think having a robust media fill qualification program is paramount to the success of an aseptic operation, right? And so a good media fill program takes into consideration the maximum number of people that are allowed in the room while the batch is being filled, the time durations, the batch size, the maximum batch size that can be filled,
equipment settings,
the equipment settings, and challenging, your media fill process appropriately so that it represents your process, and implementing some worst case elements to those media fill settings to provide an overall high degree of assurance that when you fill actual product, that your process is under control, and that the assurance is high that you're producing sterile product, right? Some sites I've seen, some sites I've seen, over challenge their media fill, right? And they put an enormous amount of people inside their clean room, and they fill twice the batch size, or they go twice as long. And so, but you don't want to do that. Why? Because it's not representative of your actual process. And if you have a failure, the investigation, it shifts when you over challenge your media fill process, because you'll say, well, we just over challenged it, so we got to back that off a little bit. But where do you identify the root cause or the failure, right? It's much harder to pinpoint that root cause. You still have to find the root cause, but you don't know where it is because you over challenged everything, right? And so your investigation is not going to be as robust if your media fill challenge or qualification process doesn't represent your processes and isn't scientifically, sound and justified. Yeah, I hope that makes sense.
Yeah.
Yeah, and for your media fills, you really want to have everything laid bare. On the backside of most production for actual products, you might have antimicrobials, you might have preservatives in there that might keep contamination, static. Might not explode like we would see if the same organism ended up in a vial of media, for instance. So, like Chris was saying, the different what's the word I'm looking for? The different conditions of the fill. Like if your process is normally 4 hours, but if it went 6 hours, that would still be okay. Well, you want to test your media fill at 6 hours of runtime. Now, or if you go beyond 6 hours, if you've only done a media fill up to 6 hours, then really you need to call it quits on that fill.
During actual production, you're saying, right?
Yes.
Yeah.
You don't want to run your actual production.
Right.
Yeah, you want to set your maximum duration based on your media fill, and you set your maximum duration on your media fill based on what your production time usually is.
Because production time is directly correlated to risk of microbial contamination. The higher the time, the more chance there is, the higher risk there is that the product is going to be contaminated.
And I think that goes for interventions as well. You want to have a high number of interventions so that you want to have a high number of interventions during your media fill so that when you're actually doing real production, you've already tested your worst case. You're not, adding so many interventions that you're compromising you're going beyond what you've tested.
Right, and that's the tricky part, is making sure that when we talk about interventions, we're talking about times when the personnel inside the clean room have to, either stop the filling process or make an adjustment to a piece of equipment that's in an ISO 5 environment, which is which is considered a sterile field of air, and it's your most critical environment. But those are times when people are entering or making manipulations to the equipment or to the filling line in your most critical area, where in the same environment where your product is temporarily exposed to the environment, right? And so you want to make sure you have a representative, number of interventions, but also you want interventions that represent the highest complexity, and rotate 1 or 2 of those into your media fill each time, so that you have covered, potential worst case scenarios, all which can occur in actual production.
Yeah, you don't want to end up in a sterility failure investigation for a product and say, well, we did this intervention, but we never actually evaluated it during a media fill. That's not where you want to be. Because then at that point, it calls into question your entire media fill strategy and program, and might require a redesign of how the facility goes about qualifying their aseptic process.
Yep, it can be tricky setting up the media fill qualification, but it's really, really important. So when you ask, I guess overall, when you ask what does good look like, it's all of those things. It's that you see when you're viewing a clean room, and then behind the scenes and everything that goes into qualifying that process, particularly the media fill. All of that goes into consideration when we say what does good look like,
Gotcha. That's really helpful.